so a proportional means it's the same thing as direct variation. So if you see direct variation, just think proportional, all right? Again, we have so many names for the same thing in math because it helps to confuse people and it makes us look really smart, right? So if I, for example, was like, hey, why don't we solve this proportion? And then later on I would say, so the direct variation equals this, then in your mind you're like, okay, were we doing a proportion or direct variation? When in actuality, they're the same thing. And most of you got lost during that, okay? Two other terms that they're going to interchange with each other, meaning they're the same, okay? They're going to call it a constant of proportionality. Constant of proportionality means it's the same exact thing as a constant of variation. These are the same thing, all right? So don't get them mixed up. They mean exactly the same thing, okay? Constant of proportionality and constant variation. Let me show you guys this, all right? So a constant of variation, let's look first at tables because that's what we did yesterday, right? We did tables first. All right, so a table is going to look something like this. I'm just telling you guys right now, always, it's the x values on the left, y values on the right in the book. If you guys set them up, you may do it differently. But usually it's like this, okay?
Do we have to
it will tell you if it's an x or a y as well. All right, another way that they'll set up a table is horizontally like this. And when they do it like this, the x's are on top, y's are on bottom. And we'll see an example like this where they have the horizontal one. When you find the constant of variation or the constant of proportionality, it's always the y value divided by the x value, okay? So in other words, if I had this in the table, let's say I had 6 and 36, right? My constant of variation, I would say, well, my y value is 36, divided by my x value is 6, it's 6. This is my constant of variation. All right, on a table, so that's the table. If you have a graph like this, usually it'd just be in quadrant 1, so there's our x and y. They're going to have some kind of line up in here, like this, right? And this will go on. They're going to give you a point maybe right here, which would be, I don't know what that is, 3, 4 maybe, right? Well, if your point is 3, 4, then how would I find the constant of, oh, that should go through the origin. All right, let me start that over, okay? So we need the line to go through the origin. That's as close as I can get it, okay? So if that goes through the origin, yeah, it'll still say this is 3/4 because it's proportional. All I've got to do is take the y value divided by the x, okay? Which is 3, so there's my constant of proportionality or variation, constant of variation, okay?
Is it always y divided by x?
Yes, always y divided by x. The nice thing is, if you forget this, there's a poster with it, y divided by x, bam. Right there, right? Y divided by x's. We'll get into the slope and rate of change stuff later, which some of you may have gone over in elementary, but I'm saving that for later because it's a lot more important for you to know that than this. We went over tables, graphs. Finally, you're looking at equations, right? Let's look at an equation like y equals, give me a number.
5.
Let's make it -5.
Oh.
Just to be awesome, okay? All right, what is the coefficient of x? -5. This is the constant of proportionality. The coefficient is the constant of proportionality. Done. So give me a number.
10. 4.
10.
7.
4.
3.
X equals y. What's the coefficient of x?
104.
104. That's your constant of proportionality right there. Yes, Morgan? Those are the constants of proportionality. This is on page 81. So if we look at this graph, okay, see how it's got 2 and 130? If I use this point, let me zoom in here.
What kind of car is that?
If I use this point to find the constant of proportionality, what would I do? I take 130 and divide it by 2, because y divided by x
Wait,
which would give me 65.
Wait, do you do 260?
All right, if I look in the table, so here's my table.
It says the constant.
So again, it's always going to put the x's on the left, y's on the right. You're going to just, let's do the second one, okay? So we're going to use 3 and 195. So 195 divided by 3
Are you sure that's what it's called?
is 65.
Oh.
Now you do need to label these in word problems, so make it 65 over 1. 195 was represented by miles, so just label it miles, top. So that's miles on top. So you'll have hours on bottom, so it's 65 miles per hour. Bam. Constant of proportionality. This equation, what's the constant of proportionality?
Well, how do you know it's asking for that if it doesn't even say that?
I'm asking for it. 65. This only works for proportions. So on the graph, how do I know that this graph is proportional?
There's a straight line and the origin.
Straight line through the origin. How would I know that this table is proportional?
Divide.
Yeah, just divide them all, okay? So 130 divided by 2 is 65. We already did 195 divided by 3, which is 65. So 260 divided by 4, is that 65? Yeah, these are all These are all equivalent fractions, okay? That's a 5. There you go. This example. So a cake recipe takes 3 1/4 cups of flour for 13 servings and 4 1/2 cups of flour for 18 servings. How much flour is required to make a cake that serves 28? Well, this is a proportion, so let's set up a proportion first, okay? What two things are we comparing? Cups and servings. So do you guys want cups on top or bottom? Top. Okay, so cups here, cups there, servings here, servings there. Now look, it gave us two different comparisons to use. You guys want to use 3 1/4 and 13 or 4 1/2 and 18? All right, 4 1/2 and 18, very good. We do not want mixed numbers, so let's make this a improper fraction, which would be 9 halves, okay? So since that's 9 1/2 cups, that's where 9 1/2 will go. And that was for 18 servings. Okay, how much flour? Is flour cups or servings? That's cups, so that's our x. And we need to know how much cups for 28 servings. Well, you just solve this the same way you would do any of the other ones, okay? So you're going to say, you're going to multiply, then divide, and that should equal, let's fill these in. So you got x, you're going to go down to 28, so 28, cross to 9 halves, down here to 18, back to x, set up your fishy method, just solve this, all right? And what do you get? 28 times 9 halves divided by 18. Is it 7? Very good. It's 7, but it's not just 7. It's 7 cups. Okay, so let's look at this one. It says determine whether each linear relationship is a direct variation, which means that we need to know if it's proportional. And we need to get in the habit of doing the y's divided by the x's, okay? So let's do this first one. So this one would be 4 over 20, which is the same as 1/5, okay? So this next one is 5 over 25, which is the same as 1/5. Same with 6 over 30, still be 1/5. And 7 over 35 is 1/5. So we know that this is a direct variation. Now we just need to state the constant of variation. Well, we just found it 4 times. It's 1/5, okay? Because it's the y value divided by the x value. This is a graph, and since direct variation is the same as proportional, we can just look at this. We can see that it goes through the origin, and it's a straight line. So we can say that this one is definitely proportional, okay? But what it's asking for is the rate in inches per minute. So again, inches is y, minutes is x's. So take the x value, sorry, the y value, which is 2. Let's use this point, 2, and divide it by the x value, which is 5. Bam. There's no need to do any decimals here. It's 2, and it said it was in inches per minute. In addition to that, you can see, so 2 over 5. So 2 is represented by the y. It told you it was in inches. And the x's, it told you was in minutes. So this is our rate. You could also say that it's 2/5 inches per 1 minute if you want a unit rate. Alright, so this one is kind of like the cups and the servings example, because it's given us two values that we can use. We can use 2 minutes and 52 feet, or we can use 5 minutes and 130 feet. Okay, it really doesn't matter which one we use, but let's set up our proportion, alright? At what rate is the scuba diver ascending? So let's say it's a unit rate. So let's do, it's a descending, so it's going to be in speed, which is going to need to be, in this case, feet per minute. Okay, so we want the same label for both, feet per minute. Okay, so let's use that first one. We've got 2 minutes, and we've got 52 feet. So we just need to figure this one out, alright? Well, as it turns out, we just solve these the same as we would any other one. Multiply, divide, equals. So you go down, you see 1, come up to 52. Now divide by 2, that'll give you the x. So 1 times 52 is 52, divided by 2 is 26. Now this isn't just 26, we need to look back at our original proportion. X, it was in feet, so this is 26 feet. But not only is it 26 feet, because it is a rate, it's 26 feet. Yes, we do need the rest of that proportion there. 26 feet per minute. Alright, this one we're just looking for the constant of proportionality, okay? So, the first thing we need to look at is equations, alright? How to tell if an equation is proportional. Well, let's look at an example, okay? So when you see an equation, you'll see it in the form of y equals some number, any number really, negative 22x, okay? If you see this, you're good. That's proportional. What you don't want to see is when it starts adding and subtracting any other number. Well, some of you know that you could add a phantom zero. That's fine. Just know that it can go away, so it would look like this anyways. Well, that's good because now it's proportional. But once you start seeing some addition or subtraction of it, some other number like 0.5, now it is no longer proportional. And the reason, and we'll find this out later, the reason is because now it no longer goes through the origin. It's still linear, but it just doesn't go through the origin. So in this example, of course, we can see that it's not adding or subtracting anything. But if we look here, that's our equation. So 10x, y equals 10x. So 10 is the coefficient of x. That's our constant of proportionality, which it confirms here at the end of this example. So on this example, once again, all we're doing is looking at this equation, y equals 55x. Okay, so there's no addition or subtraction on this one, so it is proportional, or it is a direct variation. It's the same thing. The constant of proportionality is 55. But this is a word problem, so we need labels with this, okay? So it's always, let's make that a fraction, 55 over 1. Take your distance, which is our y, because it's y over x. Y is represented by miles. Distance traveled in miles, divided by the x, which is represented by hours. So miles per hour, there's a speed. That's our final answer. Alright, in this example, all you've got to do is take, if you're looking at the table, just take the bottom number, 11, divided by the top number, 1. Because this is our y, this is our x, 11 divided by 1. Does that equal 19 divided by 2? Well, in this case, it does not, so this is not a direct variation. If you were to graph it, you can see that this line is straight, however, it does not go through the origin. In the word problem, you can see as well that there's a $3 delivery charge. That's a fee, alright? Since there's a fee, this is not proportional.